Hello everyone. In today's video, I'm explaining about a very important oxidizing agent, that is PCC, Pyridinium Chloro Chromate. So by seeing the title, you will get the doubt, what is the meaning of oxidizing agent? Oxidizing agent is a substance which can oxidize other substance and reduces itself. So whatever substance we are using in this, it readily oxidizes other and reduces itself. So before going to that, you must know what is oxidation also. Oxidation can be defined in three different terms. One is addition of oxygens is called oxidation. Removal of hydrogens or removal of electrons also called as oxidation. So the particular substance which we are using, it readily helps for addition of oxygens or removal of hydrogens and electrons. So now let us see what is a PCC. A PCC is a Pyridinium Chloro Chromate, and which is a yellow orange colored salt. So its appearance will be yellowish orange, and it is a mild oxidizing agent. And it is used for oxidation of alcohols to form carbonyl compounds. Means what it will do? It will oxidize alcohol group to aldehydes or ketones. And the chemical formula of this particular substance is C5H5NH plus CrO3Cl-. Means it is a salt which consists of cation and anion. So you can see the structure clearly. So it consists of pyridinium cation and chlorochromate anion. Okay, so the combination of these two ions is making our PCC. So now let us see how it is prepared. Now let us see the preparation method of PCC. So PCC can be prepared by addition of pyridine into ice cold solution of chromium trioxide in the presence of concentrated HCl. So firstly, what we have to do? Take a chromium trioxide and react this chromium trioxide with HCl. So you should shift the bond between chromium and oxygen, pi bond of chromium and oxygen towards oxygen, because oxygen is electronegative element, so it attracts electrons towards itself. So it gets a negative charge, chromium gets a positive charge. So when chromium gets a positive charge, we know HCl can break as Cl minus and H plus. So this positively charged chromium reacts with the negatively charged chlorine. Otherwise, negatively charged chlorine attacks on the chromium. Okay, and forms CrCl bond. And now when you are shifting this bond, oxygen gets a negative charge, no? This negatively charged oxygen reacts with this H plus and forms a OH bond. Okay, so now this intermediate reacts with our pyridine. So you know pyridine is a heterocyclic compound which consists of nitrogen in the ring. So the nitrogen consists of lone pair of electrons on it. So you should shift the oxygen hydrogen bonds towards oxygen. The bond between oxygen and hydrogen should be shifted towards oxygen. So when you are shifting this bond towards oxygen, oxygen gets negative, hydrogen gets a positive charge. Now the lone pair of nitrogen attacks on this hydrogen and forms a NH bond. As nitrogen donates electrons to hydrogen, it gets a positive charge. So with this, we are getting a pyridinium ion. As you are shifting the bond towards oxygen, oxygen gets negative charge. So this forms as a chlorochromate ion. So the formation of two ions in the structure makes a pyridinium chlorochromate. Now let us see the applications of PCC. So PCC oxidizes primary alcohols to aldehydes, secondary alcohols to ketones. So here I am taking a primary alcohol which is oxidized to aldehyde, and means you can clearly observe the number of hydrogens are getting reduced. So removal of hydrogen is also called as oxidation. So PCC helps to oxidize a primary alcohol to aldehyde. So in this process you can observe the byproducts chromous acid and pyridinium chloride. So now you can observe the mechanism of the process. reaction. So I am taking a primary alcohol, I am taking a chlorochromate ion from PCC. So what I am doing first, I am shifting the C double bond O bond, that means CO bond, towards oxygen. So the pi bond is shifted towards oxygen. So oxygen getting a negative charge, chromium gets a positive charge. Now lone pair of electrons present on the oxygen are attacking on the positive charge of chromium and forming a new bond between oxygen and chromium. So you can see oxygen and chromium forming a new bond. Okay, so now you can observe this O gets a negative charge. Okay, as oxygen donated electrons, it is getting a positive charge. So next what happens? Next I am shifting the oxygen hydrogen bond, the bond present between the oxygen and hydrogen, towards oxygen. So as oxygen positive charge is there, we should nullify the positive charge. In order to nullify this positive charge, I am shifting the paired electrons towards oxygen. So this hydrogen can be liberated as positive ion. So now this O minus of chromium attacks on the H plus and forming a OH bond. Okay, so now this positive charge is nullified. So we can see the third step here. I am removing the chloride ion. That means in order to remove the chlorine in the form of negative ion Cl minus, I am shifting the bond of chromium and chloride towards the chlorine. So the chlorine gets a negative charge now, and whenever you are shifting the bond, chromium gets a positive charge. This positive charge and the negatively charged oxygen forming a double bond here. Okay, so here there is a formation of double bond. This double bond results in the chromate ester formation. So next what I am doing, next I am cleaving the bond between oxygen and chromium. So shifting the bonded electrons towards a chromium. So whenever you are shifting this bond, I am shifting this bond also, double bond, pi bond between chromium and oxygen towards oxygen. So whenever you are shifting the bond, oxygen gets a negative charge and this bond is cleaved. Okay, so this negatively charged oxygen attracting the hydrogen from this carbon. So in order to make the positive hydrogen as positive one, I am shifting the bonded electrons towards carbon. So carbon gets negative, this oxygen is already having a positive charge, both are getting a double bond, this double bond. Okay, so this hydrogen is now reacted with oxygen, oxide O minus ion, and forming a OH bond. So this one is coming out as a chromous acid. And next what happens, this Cl minus reacts with a pyridinium ion which is present in the mixture and coming out as a pyridinium chloride. So this is a mechanism of conversion of primary alcohol to aldehyde by using PCC. Now let us see few more applications of PCC. So PCC can oxidize the secondary alcohols to ketone. So along with this you can observe the byproducts chromous acid and pyridinium chloride. So same PCC reagent can oxidize a benzyl alcohol to benzaldehyde. Means here benzyl alcohol is one of the example for primary alcohol. Means you can see in place of R, I replaced a benzene group. So here this alcohol, benzyl alcohol, is changing into benzaldehyde by oxidation process of PCC. And same PCC can oxidize the active methylene group to keto group. Active methylene group means the CH2 group which is flanked between two electron withdrawing groups. So here the CH2 group which is present between oxygen and benzene ring. So this is the active methylene group. This active methylene group can be oxidized to keto group. So we are producing the ketones from this particular reactant. So these are the applications of PCC, and this is completely about preparation method and applications of PCC. So if you like this explanation, please share this video and subscribe this channel. Thank you so much for watching this video.